So the rest of the section just wants me to solve by the quadratic formula. I like doing those first couple problems just to show you that there's multiple ways to solve a problem. And if you get into a higher class, if you're not told a specific way to solve a problem and you recognize it can be solved multiple ways, you just pick the way that you want to solve. So for the rest of these, I'm going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. If the square root reduces and it doesn't have a radical nor an I, then I shouldn't have a plus or minus in my answer. So if the square root has no I nor a square root, then there should be, in this case, the answer has no plus or minus. But if the square root simplifies, that part of the numerator simplifies, and you're left with a square root or an I, there should have a plus or minus in your answer. Exactly like solving by the square root property. So in problem 6, I think this is readable. I'm going to emphasize this is 1z squared plus 10z minus 9 equals to 0. It's set up perfectly for the quadratic formula. The quadratic formula doesn't work for cubes and fourths. It only works for squares. You have to have 3 terms, a second power term, a first power term, and a constant equal to 0. In this case, once it's set up like that, I just pull off the numbers in order. A is 1, B is 10, C is negative 9. My answer for number 6 is going to have a square root or an I in it. I'm not sure which. Your answer for number 5 won't. So they don't match up perfectly. If the B is negative, it needs to be in a parentheses. If the B is positive, it doesn't need to be in a parentheses. So negative B, that's a big deal. If students make a mistake, negative b, the b has to be inside a parentheses. Positive b, it doesn't matter if it's in a parentheses or not, but it's absolutely necessary if you're doing the quadratic formula and the b is negative that it has to be in a parentheses. If the b is positive, the parentheses are optional. So I'm going to use the formula, use the negative sign from the formula. The b is positive, so I don't need a parentheses. I get negative 10. And then b, since it's positive, it doesn't need a parentheses, squared, minus 4 parentheses for times a times 1, parentheses for times c times minus 9, all over 2 times a, 2 times 1 in a parentheses. Under the radical is 10 squared minus 4 times 1 times negative 9. I want to see the radical simplified to a single number. So this is going to give me negative 10 plus or minus the square root of 136 over 2. Now I'm going to reduce the square root of 136. You don't have to do anything but use your calculator if you have a calculator that will reduce the square root for you. I can reduce when it's written as one fraction. It's probably safer for me to make it into 2 fractions and reduce. So I'm going to put each term in the numerator separately over the denominator. And the first fraction reduces to negative 5. The second fraction, the 2's cancel and it reduces to the square root of 34. Since there's a square root, my best answer should have a plus or minus sign. I'll let you do 5. I'll do 7 with you because it's kind of sneaky. So 7, I'm emphasizing it's 1x squared plus 6x plus 9 equals to 0. Set up perfectly for the quadratic formula. It's a sneaky problem. You should get 2 answers for these, and this is the sneaky, we say it's 2 answers, but it kind of looks like 1. But anyways, it's set up for the quadratic formula. The a is 1, the b is 6, the c is 9. The b is positive, so I don't technically need it in a parentheses. I get x equals big fraction, first thing in the numerator is a negative followed by the b. If the b is negative, it needs to go in a parentheses. If the b is positive, it doesn't matter if you do or don't put it in a parentheses. And then plus or minus square root. Under the radical, I get 6 squared. And then minus 4 times a, which is 1, times c, which is 9. And in the denominator, 2 times 1. Get the radical, simplify. The radical is 6 squared minus 4 times 1 times 9. This is special. If the radical comes out to 0, you really only get one answer. We in college algebra, we say this answer has a multiplicity of 2. This is way over technical. But that's technically what I get when I simplify the radical. The inside of the radical simplifies to 0. The denominator simplifies to 2. And the square root of 0 in the denominator comes out to be 0. The square root of 0 in the numerator comes out to be 0. So I really have two problems. My answer shouldn't have a plus or minus sign. So I should technically do this. Say x equals negative 6 plus 0 over 2. And x equals negative 6 minus 0 over 2. Both of these are going to turn out to the same number. The left one comes out to negative 6 over 2, which is negative 3, because negative 6 plus 0 is negative 6. Similarly, the right one, negative 6 minus 0 is negative 6, and negative 6 over 2 is negative 3. The algebra produced two solutions, but they're the same number. That can happen. So this one actually really only has one solution. I don't need to write negative 3 twice. We say it has x equal negative 3 has multiplicity 2. That's way too technical for a intermediate algebra class, but something you'd say in a college algebra class. Keep mowing through these. In 9, 10, 11, and 12, the b's 9, 10, and 12, the b's are negative. Let me do 10. It's set up perfectly. The a is 1. The b is negative 3. The c is 5. Again, it's negative 1, negative b plus or minus the square root of b squared minus 4ac over 2a. When the b is negative, it has to go into parentheses. So I'm going to write x equals big fraction, negative from the formula. B is negative, so it has to go into parentheses. Plus or minus the square root. B is negative, so it has to go into parentheses of negative 3 squared minus 4 times 1 times 5 over 2a, which is 2 times 1. I'll simplify the underside of the square root, which is negative 3 in a parentheses squared. If you don't get the parentheses, that's going to cause a mistake. Minus 4 times 1 times 5. Underneath the parentheses, I get negative 11. In front of the radical, the double negative is positive. The radical reduces to negative 11. The denominator comes out to be 2. Square root of negative 11 doesn't really reduce, but it turns into an I. Square roots of negatives come out to be I's. This is actually, I would say, an acceptable answer when I'm dealing with problems that have square roots or i's left. Plus or minuses can be left in your answer. Usually, if the answer has an I make the two fractions up that are implied by the numerator, and I drag the I and write it to the right of the fraction. So that would probably be a best answer for number 10. Let's work through maybe number 11 together for what it's worth. So, and hopefully you did number 9. In terms of number 9, let me write down an answer real quickly. And if it has a funky answer, maybe I'll make a comment. Oh yeah, number 9. The answer I get is 1 plus the square root of 5 times I, plus or minus the square root of 5 times I. So let's do 11 together. And 11, just in case this isn't big enough, 2w squared plus 3w minus 5 equal to 0. The a is 2, the b is 3, the c is negative 5. B is positive, so it doesn't need to be in a parentheses. I'm going to write w equals as opposed to x equal because the letter in the problem is w. And then negative b, negative followed by b, which is 3. Don't need a parentheses when the b is positive. Do need a parentheses when the b is negative. And then times b squared minus 4 times a times c, which is 4 times 2 times negative 5, over 2a, which is 2 times 2. Under the radical, I have negative 3 squared minus 4 times 2 times negative 5. The underside of the radical comes out to be 49. So this gives me w equals negative 3 plus or minus the square root of 49. The denominator comes out to be 4. I don't need my calculator. I know what the square root of 49 is. It's 7. And if to the right of the plus or minus sign there isn't an I and there isn't a square root, you need to make up the separate problems implied by the plus or minus, which is going to be negative 3 plus 7 over 4 and negative 3 minus 7 over 4. The first one, negative 3 plus 7, those have opposite signs. I subtract them and get positive 4. I still have the over 4. My first fraction with the plus in the numerator gives me the 1. The second fraction, the numerators are both minuses, so I add the numbers and keep them negative. And that fraction gives me negative 10/4. I'll divide by 2 and get negative 5/2. In terms of an answer for problem 11, it's going to be w equals to 1 and negative 5/2. I should, because I'm kind of missing something here with these problems, talk about reduction of when you can and can't reduce in the quadratic formula, and I'll kind of try to show you on my calculator. So this is just some side work on reducing. I reduce differently if there's an I, if there's a square root, or if there's not. If there's not an I or not a square root, the reduction isn't tricky. But if I had something like this, if I came out to this 6 plus 3 square root of 5 over 2. I'm not going to do the plus or minus because my calculator can't. Let me show you on my calculator what it would do for this problem. This would be the industry standard for reduction. My calculator knows what good reduction is, and it knows that that shouldn't be reduced. If I wanted to reduce this, I'll show you what I need to do. So if there isn't an I in the numerator and there's a square root left, in order to reduce, the denominator would have to go into the number to the left of the plus or minus sign and to the number in front of the square root. Let me just show you what I mean. If this was something, if I had like 8 minus 4 square root of 7 over 2, it doesn't have an I, and when I don't have an I usually don't make separate fractions up if there's a square root in the numerator. If I did 8 minus 4 square root of 7 over 2, my calculator knows that that reduces to 4 minus 2 square root of 7. And what my calculator is doing, it's scanning this. It says, can these three numbers be divided by the same number? If they can, it's going to divide them by that number and simplify. If those three numbers can't be divided by the same number and there isn't an I, it's going to leave the fraction intact. It scanned this and said, oh, all of those are divisible by 2. So it did 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. And that's how I got 4 minus 2 rad 7, because I didn't need to write the over 1. Let me just write some more. If I did like 10 minus 15 square root of 6 over 5 over 25, what I ask myself is, so if there isn't an I in the numerator and there's a square root, we usually leave a big fraction as opposed to making two small fractions. If I looked at these three numbers, if those three numbers are divisible by the same number, I divide them by that number. All of those are divisible by 5, so I go 10 divided by 5, which is 2, 15 divided by 5, which is 3, 25 divided by 5, which is 5. I'd say that's how that fraction would reduce. If I entered this on my calculator, too many fractions here, fraction 10 minus 15 rad 6 over 25, it gives me exactly this. Well, it didn't actually do that because I didn't reduce this, right, did I? Because I wrote 40 like an idiot. So if I actually wrote down what I typed in, it would give me exactly that. It gave me the one big fraction. And when we're dealing with one big fraction, it can only reduce in very special times. If I gave you something like this, 20 plus 3 rad 7 over 6, I look at these three numbers and I ask myself if those three numbers are all divisible by the same number. Well, 6 and 20 you can divide a 2 out. 3 and 6 you can divide a 3 out. I can't divide the same number from all three, so I can't reduce this fraction, or I shouldn't reduce this fraction. If I entered this on my calculator, 20 plus 3 rad 7 over 6, my calculator doesn't reduce it. So if there's a square root left in the numerator, you usually don't make two fractions up, and you only can reduce if the denominator goes into the number to the left of the plus or minus sign and the number in front of the square root. If the denominator doesn't go into both numbers, or if it goes into both numbers but not the same, then we usually don't reduce. So this guy right here didn't reduce, and this guy right here, the best answer wouldn't be reduced. The odd thing is, if the numerator has an I, then best practice is to make the two fractions up regardless. So if there's not a square root left, not an I, you always make two problems, one with the plus, one with the minus. If there's a square root left, your best answer is going to have a big fraction with two terms in the numerator, one in the denominator. If we get an I, like if I had something like 6 plus 3 square root of 2i over 4, my calculator's automatically, when it has an I, it's going to make two fractions up. That's kind of best practiced. So it's going to make this 6 over 4. It would actually have a plus or minus sign, but I can't illustrate that on my calculator. It would break both pieces in the numerator up over the denominator. First fraction reduces to 3/2. Second fraction doesn't reduce because the 3 doesn't go into the 4. I can't divide something outside a radical by something under a radical, but I can drag the I off to the right. If I entered this on my calculator, fraction 6 plus 3 square root of 2 times I over 4, you'll see that it reduces exactly like I have that reduction. So in the world of square roots, like if I had 10 minus 5 square root of 6i over 14, or how about over 15, my calculator would do this. It would say it has an I, so automatically I want to make two fractions. Without an I and there's a square root in the numerator, it only wants one fraction. It's going to make two fractions. Now it's going to reduce this. I'll reduce both of these by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. I'll divide both of these by 5. That when you divide it by 5, you get a 1. That when you divide it by 5, you get a 3. I don't need the 1. The number part of the second fraction would have a radical 6 over 3, and it'll drag the I out. Again, if I entered this on this calculator, fraction 10 minus 5 rad 6 I over 15, it'll reduce it just like that. So it's not a huge deal, but it is kind of industry standard or our math standard. If we're solving with the quadratic formula, if the numerator has a square root left, you usually leave the answer as a big fraction, and you could only reduce the big fraction if the denominator goes into the term to the left of the plus or minus sign and to the number to the left of the square root, and they go in evenly. Here, all three of these were divisible by 5. Here, they weren't all divisible by the same number, so it didn't reduce. If there isn't a square root and there isn't an I, you make up separate problems. The reduction isn't an issue. All right, we're going to get a part 3 for this video. I'll pause it now.